So, do you ever see photos like this and wonder, how the heck are these photos taken? Well, today I'm going to do my best to show you my process. To photograph deep space targets, there is some equipment you're going to need. I'm going to talk about the three main components, and then I'll go into more detail of some additional equipment you can get that will really elevate the level of photographs you can take of these targets. The first thing you're going to need is a lens or a scope. I personally started with a 400mm Nikon lens, and then I upgraded to an 8-inch Celestron telescope. Most recently, I've been shooting with a Meade 10-inch that has a focal length of about 1900 millimeters. So as you can tell, deep space photography can definitely be hard on your wallet. The next thing you're going to need is a camera. I started off with a Nikon Z5, and then I upgraded to a cooled monochrome astro camera, and the difference between the two is substantial. I'll talk about that a little bit more further in this video. The last core item you're going to need is some type of tracking mount. There are a lot of really good inexpensive options out there, like the Ioptron Skyguider Pro, but if you want to go full equatorial, the price is definitely going to add up from there. Now, as you start adding additional pieces of equipment, you're going to need a way for everything to communicate. I use the ASIAIR Plus, but you can also use a mini PC for this. You can consider this the brains of your setup, which you can control from your phone. A really impactful addition is a guide camera. Your equatorial mount will do a good job of guiding on its own, but a guide camera will give your mount live star data so you can take longer exposures and still remain on target. If you're like me and you live near a city, you can get an electronic filter wheel and load that with narrowband filters, which will help you reduce the effects of light pollution. Your entire setup can become unfocused for many different reasons. Having an electronic automatic focuser will ensure that it stays focused throughout the night. So that's everything you're going to need to get started in deep space imaging. Now let's talk more in depth about the camera and what attributes you need to keep in mind when making a selection. So the first thing to consider is the image sensor. Is it a full frame sensor? Is it a backlit CMOS sensor? How good is its quantum efficiency, etc.? Next, you want to consider the pixel size and the resolution of the image sensor. How much read noise does the camera produce? Is the camera cooled? Is the camera color or monochrome? And obviously, how much can I afford? If you had no idea what I was talking about when I said quantum efficiency, don't worry because I'm going to tell you. Quantum efficiency is a measurement of how well your image sensor detects incoming photons and is able to convert those into an electrical signal. A DSLR camera can detect about half of all incoming photons, but an astro camera can detect more than 90%. This is a massive difference compared to human eyes, which can only detect a maximum of 20% even when it's well adjusted in low light levels. So why is that so important? Well, when you're taking deep space images, the targets that you're shooting can be very far from Earth, sometimes even millions of light years away. Those targets emit light in every direction, and the further you get from the target, there will be fewer and fewer photons in a given area of space. For example, this is an image I'm working on of the Pinwheel galaxy. It is extremely important that my image sensor can detect as many photons as possible that come from this galaxy, since it is 21 million light years from us. Your scope is going to be what funnels those photons to your image sensor. I use a Schmidt-Cassegrain telescope, which uses two mirrors to focus light from a larger area into a much smaller area. By doing so, it gathers 840 times more light than the human eye. This, in conjunction with the quantum efficiency of the camera, means that a single 5-minute exposure ends up being 7.5 million times brighter than what your eyes can detect. I know that was a lot of information, so let me give you a visual of what you can expect with different equipment. To recap so far, you need a lot of equipment, including a camera, a scope, and a mount. The last two things that you need are clear skies and a lot of patience. When I talk about clear skies, I'm not just talking about free of clouds. I'm also talking about air quality and seeing conditions. Seeing conditions are how calm or how turbulent the atmosphere air is. If there is a lot of turbulence in the air, the details of your photos will not be as refined as if the air were calm and still. Patience comes into play when you get everything set up properly and then the clouds roll in. Astrophotography just takes a long time in general. What you are seeing is a series of 455 individual 5-minute long exposures of the Veil Nebula. Whenever you double the total amount of exposures that you have, you're able to cut the noise in half. This means that the total integration time needed quickly adds up with diminishing results. I feel like I've rambled on enough in this video. Hopefully my voice didn't bore you to death. I truly appreciate all of you for watching and supporting my channel. In closing, here are some photographs that I've taken from my backyard that I'm very proud of. I hope you enjoy.